All right, guys, everyone wants the work through videos. Here we go. This is the quiz review. I know there's some hard questions. The first four in particular I think are pretty tough. I'm going to work quickly through them, so pay attention, see if you can figure out how these work. This is a regular octahedron. That means all the faces are the exact same length. It does make a square in this midsection here. Every edge is 6 in this particular case. We need to find the height of a single pyramid. If you can think of this as two back-to-back pyramids. And I've talked about this several times. I know it's not super easy to understand, but there's two situations. I'm going to go over them again right now on this picture. When you have a pyramid, there are two things that I might do. I might give you the lateral edge, and you need to connect it to the height using the radius of the base. That is one possible right triangle. The other option that I can give is I might give you the slant height, and the slant height connects to the height via the apothem, right? Lateral edge goes to the corner, radius goes to the corner. Apothem goes to the middle of the side, slant height goes to the middle of the side. You have to know which one you need to work on that pyramid. It won't always be a square base. So like if it's a pentagon or hexagon or something, you might have to do some trigonometry to get the radius or the apothem. On this one, we know the lateral edge is 6, and we have this square base down here. So what we have is a square base. All the sides are 6. That means the entire diagonal is 6 root 2. This would be tougher if it was a pentagon because you would have to do pentagon work. You'd draw the right triangle and you'd have to do trigonometry to get the radius. But we know that the radius of a square is going to be exactly half of one side. So if exactly half of the diagonal. And so for this particular situation, what we have is a radius that is 3 root 2. It is half of this diagonal. So I need to work on a right triangle that is 6 and 3 root 2, and I need h, the height. So what I would do is convert this to smaller numbers. Divide by 3 would be 2. Divide by 3 would be root 2. It is usually easier if you reduce and then hit it with a Pythagorean theorem. 2 squared minus root 2 squared is 4 minus 2, which is the square root of 2. I know I'm getting real messy, but that's this number here. So h equals that number times 3. Remember, we divided by 3 to get there, so we need to multiply by 3 to go back. Your other option was just to do Pythagorean theorem straight on those numbers, which, if you have a calculator, is not too bad, but don't forget to put this in parentheses and square it. A lot of people forget the parentheses. No matter how you do it, you end up getting 3 root 2. And so the height we're going to use is 3 root 2. So we're going to do 1/3 times the area of the base. The area of the base would be 36, right? 6 times 6 is 36. Times the height we just got is 3 root 2. And then don't forget that there's another pyramid facing the other way. So there's 2 of those. So 1/2. Oh, it is not 1/2. Who messed that up? The volume of a pyramid is 1/3 BH. So it's 1/3. All right, so 1/3 times 36, that would be 12. Then times 3 is back to 36, and then times 2 would be 72 root 2. And that's our answer. Boom. Next question is another situation with the pyramid. This time the base is different. I did not make you get the height of the pyramid, but I could have. So be ready for that. It says a gazebo has a roof shaped like a pentagonal pyramid. The pentagon has edges of 6 feet. So I'm going to work on the pentagon. Remember, every single time it's a regular polygon, you draw a right triangle. You do 360 divided by how many of these would fit. If it's a pentagon, 10 of them would fit. That's going to be 360 divided by 10. So you're going to get 36 degrees. And if the base edges, if these edges are all 6, then this number here would be 3. So this would be 3 over the tan of 36. You can do trig. I promise you it checks out. But that side would be 3 over tan 36. So the pentagon, the area of the pentagon is 1/2 times the apothem, 3 over tan 36, times the perimeter. Well, if each side is 6, what's the perimeter? 60. Wait. No. Not 6 times 10. 3 times 10. There'd be 10 of those. 30. 6 times 5. 30. However you get it, the perimeter is going to be 30, I promise. So you can either do 3 times 10, there would be 10 of these, or you can do 6 times 5, there would be 5 sides, but that'd be 30. All right. So that would be 1/2 times 30 would be 15. 15 times 3 would be 45 over the tan of 36. So that's the area of this pentagon. And then they give us the heights straight up. They say the gazebo walls are 8 feet tall. So the prism, we're going to do prism plus pyramid. That's going to be the total volume. The prism has a height of 8. And it says the height of the roof, in other words, the height of the pyramid is 5. So we know these heights. So the prism is, so the volume is going to be the area of the base times the height for the prism plus 1/3 times the area, 1/3 times the area of the base times the height of the pyramid. Well, their bases are the same shape. So capital B in both cases is going to be 45 over tan 36. Oh my goodness, I'm not writing very well. Over tan 36, that's the area of the base. Its height, they told us, is 8, plus 1/3, same area, 45 over tan 36, and its height, they told us the height of the roof is 5. So 45 times 8 would be 320 plus 40, that would be 360 over tan 45. 1/3 of 45 would be 15 times 5 would be 75 over tan 45. Well, those are like terms. So 360 plus 75 would be 435 over tan 35. But they did ask us to round to the nearest thousand. So I'm going to type that in. 435 over tan 45. Guys. Okay, maybe my head's not in it. It's not 45. How many degrees is this? 36. 36. And then and then I wrote 35. What is going on? Okay, it's 36. It's 36. It's 360. It's 36. I was like, 45? I would have never done tan 45. That's a special... Oh, my goodness. Okay. And that gets you 598.726. Boom. And that's our answer. Okay. Hopefully, I do better going forward. Sorry about those 45s. Sorry about that 35. Sorry. Moving on. Probably a challenge. I don't know. Probably. What do we got going on here? Let's say John has a metal cylinder that has a volume of 100 pi. So this cylinder has a volume of 100 pi, and he's going to melt it down. Well, when you melt down and recast, you don't lose any volume. So then we have a square prism whose height will be twice the cylinder. Does square prism mean, does square prism mean cube? No. Square prism does not mean cube. So if I draw a square prism, it just means that the base is a square. So it could look like this. It might be a cube, but it doesn't have to be a cube. Okay, so what do we do here? It says the radius of the cylinder is 5. So volume is pi r squared h. So we know that 100 pi equals pi times the radius squared times the height. Well, this would be 25 pi h equals 100 pi. So how do we undo? How do we undo times 25? We divide by 25. How do you undo times pi? You divide by pi. And so the pi's cancel out, and you get a height of 4. Now remember that the rectangular prism has a height that's twice as much. So this height is 8. But I don't know the base. I don't know anything about the base other than it's a square. So if it's a square base, I can call each side x, and the area would be x squared. We know the volume is unchanged. So if we're working on the prism, volume equals area of the base times the height. So that would be 100 pi has to equal x squared times 8. So divide off the 8. That would be 50, 25. That'd be 12.5 pi equals x squared. And then we take the square root. So the square root of 12.5 pi equals 6.267. And it says round to the nearest thousand. Yeah, so 6.267 is our answer. Yeehaw! Loving it. All right. A cone is inscribed in a cube, and the length of each edge of the cube is 8 inches. So the volume of a cube we can actually think of as just being s cubed, right? It's length times width times height, but they're all the number 8. So that's going to be 8 cubed, which is what? 516? I don't know. 8 cubed. 512. Duh. 512, guys, is 512. Find the volume of the space between the cone and the cube. So the space that is not occupied by the cone inside the cube. So I need to do cube minus cone. Well, if each side is 8, isn't the radius of this going to be 4? And isn't the height going to be 8? So we actually have our cone and cube numbers here. This is going to be 512 minus, oh dear, 512 minus 1/3 pi. The cone would be radius squared, 4 squared times 8. So 512 minus all that, 4 squared, 16 times 8 is 64. So this is 512 16 times 8 would be 80 plus 48. 148. Oh, goodness. Let me just type it in. So 16 times 8. I'm all over the place. 128. This is 128 pi over 3. But they want us to round to the nearest whole number. So 512 minus 128 over 3 times pi is 378 if you round it. Got it. Perfect. All right, we got a Frustum problem. I'm going to do this pretty quick. This strategy never changes. We draw this cross section. We draw this bar. This bar represents the small radius. The bottom is the big radius. So they tell us big R is 12 and small r is 9. And we have a slant height of 6. Anytime you have a slant height, it's going to be more work. You are trying to find this height, which is the exact same thing as this height. Well, if this much of it is 9, then this much would have to be 3. If you got a good eye, 6 divided by 2 is 3. That means this number has to be 3 root 3. So the height here is going to be 3 root 3. It has to. It must. And I'm going to call this part x. If you don't know that that's 3 root 3, then do Pythagorean theorem on 6 and 3. I promise you're going to be excited when you find out I'm right. It's 3 root 3. So then we do proportions. What do the proportions tell us to do? I do left over bottom of the small triangle, and that needs to equal left over bottom of the big triangle. That'd be x plus 3 root 3 over 12. From here, you can do a few things, but I like reducing when possible. I'm going to reduce the 9 and the 12. This would be 3/4. And then you need to cross multiply. You're going to have 4 times x equals 3 times x plus 3 root 3. So 4x equals 3x plus 9 root 3. So x equals 9 root 3. That means that this x is 9 root 3. But the number we care about is the entire thing, which is 12 root 3. So the entire height's 12 root 3. And then we go to volume. We're going to do the volume of the big cone. So 1/3 pi times big radius squared times big height, 12 root 3, minus 1/3 pi times little radius squared times little height, 9 root 3. So this would be 144 times 12 divided by 3. So this would be 576 pi root 3. Over here, 81 times 9 divided by 3. This is going to be 243 pi root 3. So 576 minus 243 is 333, and don't forget you have a pi and a root 3. The order I have it here is root 3 then pi, but it's the same thing. It doesn't matter what order you multiply in. 333, root 3, pi. Woo! A grain silo is on a farm. It's 75 feet tall, and the diameter is 20 feet. The silo is topped with a hemisphere. How much grain can be stored in the silo? So let's do that first. How much grain could be stored if we filled this entire thing up? We're going to do hemisphere plus cylinder. A hemisphere is going to be 2/3 pi r cubed, right? If a full sphere is 4/3 pi r cubed, and you cut that in half, remember that division is the same thing as multiplying by the reciprocal. Well, the 4 and the 2 cancel out. It's 2/3. Or just like, what's half of 4? Half of 4/3. 2/3. Plus a cylinder is going to be pi r squared h. So it's going to be 2/3 pi times 10 cubed. That's the hemisphere. Plus pi times 10 squared. Oh, what is the height? What is the actual height of the cylinder? That's going to clock in at 65. 75 is the whole thing. 10 is the hemisphere. We are left with 65 for the height of the cylinder. So 10 times 10 times 10 is 1,000. And so that's going to be 2,000 over 3 pi. 65 times 100 is going to be plus 6,500 pi. Now, these are over 3, so you'd want to get a common denominator. 6,500 times 3 would be 19,500 pi. And then this would be 2,000 still. So you add those together, you get 21,500 pi over 3. So that's our first answer, 21,500 pi. That is the volume of the entire thing. All right. I'm going to clean this up. That's not a 6. I know someone's like, what? I know it's not a 6. All right. And then each barrel holds 4 feet cubed. That's not a lot. So it's going to take a lot of barrels to fill this thing up. I'm going to take that number and divide it by 4. So that's going to be a huge number, 21,500 pi divided by 3. That's how much space we have, divided by 4. And I get 5628 point, we'll say 0.7. But it says we want to fill the silo entirely, right? Fill it all the way to the top of the hemisphere. We are filling in the entire thing. So if we buy 5628, that would not be enough. We must buy 5629. We will have some left over, but there's no mention of us caring about that. So it's okay to have extra in this particular case. They want to fill the entire thing, so we got to make sure we have enough to do that. A sphere is submerged into a cylinder holding water. The radius of the cylindrical tank is 4 centimeters. Before the sphere was put into the tank, it was 3. So before, it's at 3. After submerging, it's now at 3.2. Everything's in centimeters. We're good there. What is the volume of the sphere? So basically, remember, water takes the shape of the object it's in. And so we need to find the shape of this small cylinder. Right? We know that the radius is 4, so it's going to be pi times 4 squared, and the only height we care about is going from 3 to 3.2. The only height we care about is 0.2. That's it. And so that's going to be 16 times 0.2, or 16 times 1/5. 16 times 0.2 is 3.2 pi. It says you can type the coefficient as a decimal or a fraction. The fraction would be 16/5 pi. Either one of those are good. You're just typing in the coefficient. But the only height you care about is the displaced height. This height represents the volume of this marble being dropped inside. What is the volume of the solid formed by rotating the region bound by y equals 8, hoi vux, y equals 8, hoi horizontal. Y equals 6 over 7x plus 2. So if I start at plus 2, I'm going to go up 6 and over 7. That's going to land me here. Maybe I just need to draw that much. We'll see. I'm just going to draw that much. And it's on the domain from 0 to 7. Well, that works out nicely. So here's x equals 0, and we've already stopped at 7. I'm going to delete that. We are just caring about this triangle. And we're going around the y-axis. So if this is at 7, 8, I need to go to negative 7, 8. And I know the announcements are going. We're going to negative 7, 8, and we're rotating around the y-axis. And so that's going to make a cone. The radius of our cone would go from 0 to 7, so r equals 7. And our height is from 2 to 8. The height would be 6. So it's going to be 1/3 pi times r squared times h. So 1/3 of 6 is 2 times 49 is going to be 98 pi. And so not much to that. You do have to get the graph in there. You do have to rotate around the correct axis. All right, one more question. A rectangular prism is length times width times height. That's the easiest way to do it. They tell you the volume is 10080. They tell you, unit alert, unit alert, unit alert. I don't care about units, but I do pay attention to them. I don't want to convert this number that's already in volume. I want to focus on the feet. I'm going to change feet to inches since this is already in volume and the answer over here is in inches. So inches is where we want to be. So it's 1 foot is 12 inches. So this would be 24, and 12 times 5, this would be 60 inches. So keeping that in mind, okay, we're good. So 10080 would equal length, 24, times width, 60, and then we want to know the height. So divide by 24, divide by 60, so 10080 divided by 24, divided by 60, and the height would have to clock in at 7. You got to use the correct units. If you were trying to convert this number into feet, you would have to do 10080. What would you have to do? If normally feet to inches is times 12, you would have to do times 12 cubed. And most people don't remember to do that. Oh, sorry, that's inches. We're going the other way. In inches, you'd have to divide by 12 cubed, right? To go from inches to feet, you'd have to divide by 12. Most people just divide by 12 when you need to divide by 12 cubed when you're working with volume. And since this was already in volume, that's what you would have to do. That would be hard to pull off for a lot of people. All right, sorry about those announcements at the end. Hopefully they weren't too distracting. We just did the whole review. That was a lot of fun. I'll see you guys next time.